Welcome, everyone, to this explainer. Okay, we are diving into a really fascinating and honestly critical challenge in the world of enterprise machine learning today. We're going to break down exactly how you can secure highly sensitive machine learning environments by using a multi-account strategy as a hard security boundary. If you've ever wondered how the biggest organizations safely build, test, and deploy AI without exposing their most critical data, well, you are in the exact right place. Let's get into it.
Think about this for just a second. Would you ever build a highly secure bank vault right smack in the middle of a public lobby? No way, right? Of course not. You'd put it behind locked doors, security checkpoints, and restricted hallways. Yet, surprisingly, so many organizations build their highly sensitive machine learning models in flat, vulnerable, wide open environments. They're literally mixing their experimental data science work right alongside their production data. Today, we're going to fundamentally rethink that architecture using what we call a high-security office building analogy.
To really get why this matters, we have to talk about the blast radius. In cloud architecture, the blast radius is the maximum potential impact or damage that's caused by a single security event or a compromised environment. Think about it. If an experimental piece of code goes rogue, how far can the damage actually spread? To shrink that blast radius in machine learning, we absolutely must separate our environments into distinct AWS accounts. By treating each AWS account as a physical, hard security boundary, kind of like soundproof, fire-resistant walls between rooms, we contain any potential issues right where they start.
So think of today's agenda as our floor plan for this high-security office building. We'll start by looking at limiting the blast radius, then we'll tour the secure foundation rooms, check out the tooling security hub, examine the badge scanners and security gates, actually enter the bank vault, and finally, we'll visit the architect's governance office. All right, let's jump right into our first section, limiting that blast radius by drawing up a blueprint.
What's really interesting here is how explicitly this maps out our entire building blueprint. We've got this integrated AWS SageMaker MLOps architecture. The governed data lake at the very bottom acts as our foundational layer. Then, right above it, we have our completely separate trust zones: experimentation, dev/build, pre-prod, and production. And sitting over all of that is the tooling and governance account. Notice those little security gates, SG1 through 4. Those act as our badge scanners between the trust zones. See, the path a model takes isn't just about moving code around. It's about moving from low-trust environments up to the highest trust environments, and that requires solid evidence and strict approvals at every single step.
Okay, let's move into the first rooms on our tour, the secure foundation rooms, which handle our data lake and experiments. First up, we have the data lake. Think of this as the secure warehouse. It is absolutely not just a place to dump files. It is the vital upstream data protection boundary for every single downstream machine learning account. It relies heavily on fine-grained access controls using AWS Lake Formation to act as your ultimate data guard. Then, right next door, we have the experimentation account. Now, this is the creative studio. Data scientists need flexibility here, right? They're using sampled, masked, or anonymized data sets pulled from the warehouse. Because it's essentially a sandbox, they might even have controlled internet access to download new open source libraries. But because it has that internet access, it is inherently a lower trust zone.
But as we move from that creative studio to the next room, the trust level completely shifts. Think of the dev or build account as the automated factory floor. Here, we lock things down. Those flexible notebooks from the experimentation phase, they get turned into rigorous, repeatable pipeline code. Internet access is heavily restricted here or even completely shut off because this environment might process real production-like data. It's actually your first real production boundary where human error is drastically reduced by automated SageMaker ML pipelines. You can't just casually stroll from the studio onto the factory floor. You have to pass a strict security check.
Moving right along, let's step into the tooling security hub, our command center. The tooling account is literally the brain of our secure building. It doesn't actually hold any raw business data. Instead, it holds the rules, the code, and the central records. It hosts your source code repositories, like AWS Code Commit, and the CI/CD automated deployment pipelines. Crucially, it houses the SageMaker Model Registry, which is the official verified inventory of all your approved models. By centralizing all of this, the tooling account ensures that no single data scientist or engineer can just unilaterally push code into a live environment. It strictly enforces a separation of duties. It's the ultimate security hub that distributes policy guardrails out to all the other rooms. Now for the real climax of our architecture, the badge scanners and security gates that control all movement. Between our rooms, we've set up 4 explicit security gates, or SGs, that act as mandatory automated badge scanners. Promotion to the next room is totally blocked unless these checks pass. Gate 1 sits between the studio and the factory floor, ensuring notebooks are translated into proper pipeline code, and that IAM roles are completely separated. Gate 2, that is your strongest automated gate. It scans for vulnerabilities and checks artifact integrity before code can even be considered for a release. Then we have Gate 3, which introduces the human element. It demands manual business sign-off and rigorous stress testing before a model gets anywhere near production. And finally, Gate 4. That ensures once something is live, it is continuously monitored for any anomalous behavior.
This really proves that moving models isn't just a simple stroll down an open hallway. In the pre-production flow, a model is sitting in the registry, and Gate 1 actually requires a lead data scientist to manually review its key performance indicators. If it's approved, it moves into automated integration and stress tests, but even after passing all those technical hurdles, it hits Gate 2, a mandatory business sign-off. If the business stakeholders reject it for any reason, the deployment fails entirely and the team gets notified. Only when explicit manual approval is given does this system promote the model to the final production environment.
All right, it's time to shift gears and enter the final, most locked-down environments on our tour, live production.
Let's compare these last 2 rooms. The pre-production account is essentially your dress rehearsal. It's an exact one-to-one mirror of production, used specifically for validating the release candidate. It uses non-live representative data to catch any reliability or security failures before they ever have a chance to impact a customer. Production, on the other hand, is the bank vault. This is the live inference environment serving the actual business. It operates on the absolute highest sensitivity classification. There is 0 direct user access here. Everything, and I mean everything, is deployed strictly through automated CI/CD pipelines. Console access is locked down behind strict break-glass emergency procedures with multi-factor authentication. So the absolutely crucial point here, especially if you're looking at this from a Chief Information Security Officer's perspective, is captured perfectly in this idea. In a multi-environment MLOps platform, the highest risk is not only bad model quality, it is uncontrolled promotion between trust zones. We spend so much time worrying if a model is mathematically accurate, but honestly, the bigger enterprise threat is a flawed or compromised model somehow slipping from an experimental sandbox into live production without a strict, highly auditable trail of evidence. And once a model is actually inside the bank vaults, we definitely don't just leave it alone. That's where Gate 4 kicks into action. Live inference is happening, sure, but it is constantly being watched by a model monitor. This monitor tracks data drift, model drift, and bias. If drift is detected, meaning the model starts behaving strangely compared to the data it was trained on, the system can actually trigger an automated rollback to a previous safe version. Meanwhile, all the healthy metrics and alerts are shipped straight out to a centralized security monitoring hub. So yeah, our bank vault is heavily guarded, 24/7.
Finally, let's conclude our tour by visiting the room that actually builds this entire structure, the architect's governance office.
If you've got multiple data science teams across a large enterprise, you literally can't manually build these secure multi-account structures every single time. It's just not scalable. That's where the Advanced Analytics Governance account comes into play. It operates as the highly privileged IT control plane, using infrastructure as code tools like AWS CloudFormation and the AWS Service Catalog. IT administrators can securely stamp out exact replicas of our building blueprint. They can give each new data science team their own dedicated data lake, experimentation, dev, and prod accounts, sometimes with just one click. It also uses tools like Amazon DynamoDB to catalog metadata so your auditors always know exactly which team owns which secure environments. It keeps everything perfectly organized. We've definitely covered a lot of ground today, exploring how separating trust zones vastly reduces the blast radius of machine learning workloads. So, I want to leave you with this final, provocative thought to chew on. If every promotion boundary in your system truly should be a security boundary, take a hard look at your own architecture. Is your ML pipeline a vulnerable open hallway where absolutely anyone can just wander from the lobby straight into the vault? Or is it a fully secure office building with explicit badge scanners at every single door? Thanks so much for joining me for this explainer. See you next time.